Okay. So in first chapter, we have seen the different applications of plastic, how the plastic are processing, and different methods of processing. Okay, how the and one more thing we have studied from raw material, from wastage material to raw material to finish the product. The whole journey of plastic, how it's going in the industry. So this is we have studied in the up to last lecture. Okay. So today testing methods of plastic. Okay. So testing is always necessary. Okay. Suppose you guys also suppose you have done any one project. Okay. So manufacturing of project, design of project is very easy. But after manufacturing, designing, we need to check it or we need to test that project. Either that project is up to the benchmark or not. In plastic industry also, after manufacturing the plastic from the wastage material to raw material to finished product, after completion of this whole journey, we need to test that plastic product to check the product is up to the benchmark or not. Okay. So for that purposes, we have different testing also. Okay. So we in machine design one also, we have studied the different testing methods. Okay. Tensile test, compressive test, shear test. So different by using the different calculations or by using the different designs of analysis software, we just made the analysis and checked that the product is will sustain the respective load or not. Okay. So here also in plastic industry also we have different testing methods of plastic also. First one is the tensile testing. Tensile, of course, you guys have known that tensile means it is just we are checking the pulling capacity of that plastic. Next there is flexural testing, impact testing, tensile impact energy testing, flammability testing, electrical property testing, and quality control testing. So these are the methods. Okay, but for our study, just we have the compressive study, not up to the depth. Not we are just going to uh, compressive study. Okay, so first thing is that we are going to study the tensile testing. Of course, tensile testing we are just uh, going to check the tensile trace. Okay, just I will raise one concept to you guys. You guys have I thought know the word tensile trace and tensile load. Okay, so some guys may they have confusion between the tensile trace and tensile load. Okay, some student they are just imagining both are the same. No, both are not the same. I will give the example. Okay, so समजा आपण एखाद्या ठिकाणी काम करतो आणि आपल्याला समजा आपल्या कामाचा लोड आपल्याला जास्त लोड असेल कामाचा, तर आपण काय होतो आपण काय म्हणतो की बाबा नाही जास्त लोड कामाचा लोड असल्यामुळं मी ट्रेस मध्ये येतो. सो सेम थिंग इन द plastic product also. If the load is increases, the trace will get into the trace will get generated. Okay, so we have to apply the load up to that point where the trace will be a zero. Okay, and in some cases we need to generate the couples of traces. So this is what we are not going up to that level. So give the heading tensile methods of plastic and write down this testing method. Take a 2 minute time and write it. So we'll go further. So impact loading also some guys they have no. Impact means I will give the example. The load on our shock absorber. Okay, shock absorber is always working in the impact loading condition. Okay, because sometimes it is undesirable load. We can or we can say unexpected load. This impact loading. So for that purposes we have shock absorber is the best option. And also in a plastic industry we can take the example of press also, hammer also. Hammer is the best example. Hammering is the best example of impact loading or testing. So for that purpose, we need to make a testing. So write down this method, testing methods of plastic. Write fast. Okay. So hope you guys have complete. Go for next page. So what is tensile testing? Okay. So tensile means suppose you take a example of propeller shaft also, which we are using for our drive purposes in four wheeler or six. We can say six fill trucks or sorry 8 or whatever 16. Okay. So again, I will in daily routine I will give an example where the tensile trace is going to generate. Yeah, simple example. You take your rubber, okay, and you take your rubber and just stretch that rubber, okay, up to the certain level. You will stretch that rubber, and if you can remove the load, again that rubber will come to original shape. Again you stretch, again remove, it will again its original shape. But beyond some certain load, if you guys will trace or trace that rubber, then there will be the small scratch will happen and the rubber will get break. Okay. So in tensile testing, what we are just calculating, up to the what load the rubber we can stretch without failure. Okay. In tensile testing, what we are calculating, up to the what load we can stretch that rubber, so the rubber will not get failure. Okay. So such testing we are doing in the tensile testing. Tensile testing is a way of determining the how something will react when it pulled apart, when a force is applied to its tension. Okay. So this is just a small I can say description, just to take a 2 minutes because it's not difficult. Okay. Again, I will give one example so you guys will get understood. So in daily routine, rubber, anything, any example? So you guys have observed any example? Okay, you take an example of wire also. So this is also example of tension. Sorry, rubber wire. So this is the example also. So they just write it. Write the tensile testing. Give the heading. Okay. in मराठीमध्ये सांगण्यानंतर टेक्सटाईल जे टेस्टिंग असतं जे आपण एखादा समजा एखादा शाफ्ट आहे दोन्ही बाजून त्याला आपण पुल करतोय, ज्याला आपण ओढतोय, तर त्याचं फेल्युअर होत असतं. तर ते फेल्युअर किती लोडला होईल ते आपण याच्यामध्ये कॅल्क्युलेट करतो टेक्सटाईल टेस्टिंग. आय थॉट यू इन मशीन डिझाइन यू गाईज हॅव स्टडीड इट. सो टेक अ 2 minute टाइम अँड राईट इट. Okay. So hope is it completed? Please message inbox. Is it completed? Anybody please message inbox. So I will understood. Okay. So these are the some standard methods, standard polymer tensile testing methods. Okay, D638, D5083. This method means how do we can say just different methods for testing purposes. Okay, so D882 thin first one D638 test method for tensile properties of plastic. Next D5083 fiber reinforced thermosetting laminate. Next, D882 thin plasticity means for a different component or for different structured component, there are the different design the method. Okay, so that is what we have D1922. Just we are what we are doing on in this method, just tearing rest of various plastic films and the thin sitting by the pendulum method. Okay, next D412. Uh, this is for we can say thermoplastic material. For that purposes, we are using the D412, and for thermosetting plastic material, we are using the D5083. Next is D3039, and we can call it as a D30 and M also. There is this different method, but small changes. So this is just we are what we are doing. Just by matrix method, we are just calculating polymer matrix composite material. Or here in this process, we are just using the matrices for the calculation of tensile loading. So these are the different methods for the different plastic component, or we can say for the different structured plastic components. Okay, so we are not going to study in depth because we have just a overview. So just write down the use the heading standard polymer tensile testing methods. Okay, and write down this. Okay, so hope you guys have completed. So go for the next slide. So advantages and we can say advantages of testing method. So why the testing methods are necessary? So tensile testing provides the data on integrity and safety of material, of course, component and product, helping manufacturer ensure that their finished products are fit for purposes and manufactured to high quality. Okay, so of course not for tensile, for every testing purposes. Why the testing is required? To ensure that our product has a manufactured which is good for use, and it will give the uh, I mean highest quality feedback to us. Okay, so suppose you guys have a produced any one product in market. Okay, but you without testing, suppose without testing you have a we can say launched your product in the market, and after that there will be some customer after that without because of testing problem. If suppose customer will face some problems, then they will give the bad review to our product. Okay, so for that purposes testing is always necessary, because we'll get ensure that our product having highest quality as compared with the competitor. So for that purposes, not tensile, we can tensile also necessary, but different required testing methods are also necessary as per the loading condition. Okay, suppose in some cases, if there will be the compressive stress will happen, or compressive loading will be there, then at that condition we need to test our product for the compressive stress. Okay, our product is capable to take a compressive stress or not. Okay, suppose if there impact testing, then any as per the loading condition, as per our product environment, we need to implement the use the testing method for the test type purposes. Okay, so the data produced in the tensile test can be used in the different way. Okay, first one, to determine the batch quality. So this is just a general. Okay, so suppose suppose you take an example of shaft. Okay, you have one shaft, and you need to design that shaft for 200 kg tensile load. Okay, so and you guys have a designed that for 300 kg load. Okay, so why the three for you are designing for 300 kg? Okay, suppose you have one or two or 2.5 is the factor of safety, then it will become up to 230 kg, 240 kg. Okay, so because if we're going to increase the strength of our product, make sure that our product cost will be increases. Okay, so we have to design our product in such a way that our product will take the load, whatever the mentioned load from the customer, that load will our product take without any failure.
In other way, but in other way, the cost of our product also be low. So make sure that for that purposes we need to make a testing, and from that testing, whatever the outputs that we are getting, we need to check with its cost reduction purposes. Okay, so this is a data is required from the testing methods. Okay, write down this page, write down the point advantages of tensile testing, and write down also next the use of data in different way. So write down this page.
Okay, write it fast. Okay, is it completed? Roll number 4. Roll number 4. Is it completed?
No, sir.
Okay, I thought you have today's first lecture.
सर मी हॉस्पिटलमध्ये म्हणजे म्हणजे मला लिहिता नाही येत, फक्त अटेंड करते.
बरं बरं बरं. काय झालं तर आता बरे आहे ना तब्येत?
बरे.
आता हॉस्पिटलमध्ये जाईल का?
हा.
बरं बरं ठीक आहे. काय अडचण तर कॉल कर त्याला. ठीक.
थँक्यू.
Okay. Thank you. So go for the next one. So this is just we have setup. I thought for I thought in last year in metallurgy you guys have tested the component. Okay, so this is just a basic approach of tensile testing. Okay, so you may guys have handled this machine. Okay, so just see, this is a base, this is a table, and this is fixed crosshead, and this is movable crosshead. This crosshead is movable because of screw. Okay, screw and motor arrangement. Okay, and this is column for holding purposes. Fixed crosshead and moving crosshead holding purposes. These two columns are with us, and this is specimen. Means what is our component will be at this place. Okay. So such arrangement. I thought everyone has seen it. Okay. At first stage, when the tensile load is applied, again we increases the tensile load. Okay. How the failure is happening? Initially, there is a small neck here I have shown here, and after that, such a failure will happen. Okay. So this is the arrangement. I thought everyone has seen this machine. I'm right? Everyone has. Is it anybody has a problem? I thought for metallurgy, you guys have studied this machine. I'm right? Anybody please? If no, then we'll go for the animation. Have you seen this machine in college? Reply fast. You guys know about the UTM machine? Universal testing machine. Yes or no? Okay. Roll number 50. Roll number 8. Roll number 6.
No, sir.
Uh, have you studied the UTM machine, Universal Testing Machine for testing purposes?
In theory, I think, sir, but in not practical.
Okay. So what we'll do, we'll I will show one animation. Okay. Okay. So in our college, in diploma, this machine is available. I thought everyone has seen, but you guys may forgot which is an testing machine. So yeah, here is we have one video. So universal testing machine. Just okay. These are the screw. This is a lower plate. Okay. Okay. These are the screw, and here is inside this for the this block there is inside threading also. And here we are just we are clamping our job here on this plate. Okay, I thought they have not tested. So let us will see. So you guys will get understood. Okay, you do one thing. You just check if so just go to the YouTube and just search it. So you will get a universal testing machine video. Okay, so just write down this page, but make sure that after completion of this lecture, you guys will check the universal testing machine videos or animation on YouTube. So you will get a total video. Okay, but in our diploma and in for your metallurgy subject also, and in our diploma strength of material or SOM, or you can say MOM for the MOM lab, there is a universal testing machine is available, practical is available. So you guys just see the video. Okay, take a 2 minute time and write down it. Okay, so I'll just describe what is happening. Okay, so just this is a fixed plate. Above is a fixed plate, or we can say this is a fixed crossover. Okay, these two verticals, these two columns, and this plate is a fixed, and this below plate, this plate is a movable plate because of this screw. This column are nothing but these are the screw. Okay, due to the motor, this column screw get rotated, and because of that, this plate will goes up and down, up and down. Okay, and due to up and down, there will be the tensile load on this specimen. Okay, so just draw the diagram and write down. Just don't take more time. Just to take a 2 minute time. So we have to finish today first chapter. So just take a 2-3 minute time and write down it.
Is it completed? So hope is it completed? So if not, then take a screenshot and write it later. Take a screenshot and write it later. Okay. So we'll go for the next testing method. So because take a screenshot. Okay. So this is not required. Okay. So next give the name ASTMD790, or we can call it as secure testing, and just draw this diagram. So this is not a difficult. Okay, so this is our, we can say, base for testing purposes, and this is a load, and this is our specimen. Okay, here just we are what will you call, calculating the uh, tensile testing on the fiber, its outer fiber. Just draw a small diagram, or you can do one thing, you just take a screenshot. Okay, take a screenshot, not necessary to write because this is not for our syllabus. Okay, take screenshot, this is for your study purposes. Okay, so this is also, take a screenshot, this is for your additional purposes. Otherwise you do one thing, you give the heading and draw this diagram, 2D diagram also. Give the heading flexure testing and draw this diagram. Okay, so this is the arrangement. This is simple one, it's not a difficult. Okay, so this is a load, this is a test specimen, and what will happen here, we have shown in the block what will happen here. If you say this is component, the on the inner fiber there will be the compressive deformation, and outer fiber there will be the tensile deformation. Okay, so for this testing I will give an example. Okay, suppose you have plastic tree. Okay, okay, so and you want to break that plastic tree. So what you will do, you, and one more additional example in metallurgy I will give. Okay, so take an example of wire. Okay, you have a metal wire having 1 mm, a small 1 mm diameter, and suppose you want to
break that wire. So what will happen? You will just initially you will apply the just we can say uh, flexure testing method, sorry, flexure loading condition, and you will break that. Here also same we have. Okay, so due to this load, what will happen? It will this test piece will try to bend. It will get a bend. Okay, it will get a bend, and how it will get a bend? At its the top fiber there will be the compressive deformation, and its the bottom fiber there will be the tensile. Okay, draw this diagram. Draw this diagram and shown this in blue color. We have shown the output. What will happen? Okay, due to this load. Okay, so we need to check also this tensile deformation also. Our product must take the tensile deformation without any failure. Okay, so give the heading flexure testing and draw this diagram. Okay, Okay, so that's it for today. We'll take attendance. So complete it in 1 minute. So in last 5 minutes, we'll take attendance and we'll stop here. Okay, so plastic engineering is not difficult. Just when we have different processes, different testing method, different manufacturing process, we need to study it, and we need to just understand how the plastic industry are working, how the plastic products we are manufacturing, and how we are differentiating the plastic industry with the metal industry. So that's it for the plastic engineering. It's not a big challenge for us. Okay, whole processes are the same. Okay, but there is quite change. Okay, and nowadays plastic products and plastic industry are playing a very important role in cost reduction also. So that's it for our plastic engineering. Okay, so hope you guys have completed it, and we'll stop here. So if not, then take a screenshot. Take a screenshot and you just complete it. Okay, so